Okay, so we started on Tuesday with factoring polynomials, right? And the concept of factoring polynomials, and we talked about long division. But what we did here first off was I gave you this analogy. Hey, let's do P of 3, and we found that P of 3 equal 32. And then we did long division of this factor, and we found that the remainder was 32. And they matched. And what we found then was an x minus 3, when you solve for 0, set it equal to 0 and solve, is x equal 3, hence the two relate. All right, so that was the thought, which led us then to the remainder theorem. Now I get rid of all this ink. Which led us to the remainder theorem, which said that indeed when you put that factor in, the result will be the remainder. And that was, by the way, how you would have done the bonus on the quiz, right? Just simply stick in the value when you set that binomial equal to 0 instead of doing long division. All right, and then that led us to the factor theorem. And the factor theorem is what we're after, which basically says if your remainder is 0, then it is a factor. And that's what we want, because we want factors. So we're after finding these zeros. If the remainder is a 0, then it is a factor. Did we do any of these two examples, 1 and 2? Okay, so that's as far as we've gotten. Okay, so let's go ahead and work these couple examples. And I got to roll today. We got a lot to cover, but that's okay. We'll get there. Okay, so in order to use the factor theorem, remember, the x minus 2, if you have trouble understanding that we're going to use x equal to, just simply set the binomial equal to 0, and you can clearly see then we want f of 2. And we're just going to stick this in for everywhere where our variable is located in the function. We're going to stick in the 2, right? So again, I'm taking the 5 where the x is the parentheses, quantity squared, minus 17 where the x is parentheses, and then the plus 14, and I'm sticking those 2's in. All right, order of operations. 2 squared is 4, and then 4 times 5 is 20. Negative 17 times 2 is a negative 34, plus your 14. And therefore, f of negative 2 is 0. And we can therefore say, yes, it's a factor because the remainder is 0. And this is what we're after. We need to find the factors. Again, why do we want the factors? Because the factors give us the zeros of the polynomial, and those are the key points. So for number 2, what would you use for the independent variable? It would be f of what? F of negative 1. So that's what we need to do here. So go ahead and belt that out, f of negative 1. And that was similar to the quiz, right? I think I did a negative 1 on your quiz. Be careful with your positives and negatives. I'm going to write a couple extra steps just to be clear so you guys might know where you made a mistake if it happens, if perchance you did. And hopefully again you got 0. And And therefore, then the conclusion is yes. You get the zero remainder, it's a factor. Because it divides in evenly, right? Divides, that should make sense. It divides evenly in the polynomial, therefore it's a factor. If you had a 7 divided by a 2, is 2 a factor of 7? No, 2 doesn't divide evenly into 7. You know, if you had 8, though, divided by 2, is 2 a factor of 8? Yeah, 2 divides evenly in 8. So again, the binomial divides evenly into it. The evidence of that is a zero remainder. So therefore, then we know it's a factor. And again, it saves us time of doing it this way instead of doing long division. All right? Next. All right, C. C is the rational root theorem. I will not ask you that name on a quiz or test. The rational root theorem. I may reference it in my speech, but I won't give that to you as a test question. All right, the rational root theorem. Some students stumble at this notation. I know it looks a little intimidating. It's really not as bad as it looks. So let me actually pull my shade up so we can just focus on it. Okay. All it is representative of a polynomial with all variables. So the a to the n is the number, the coefficient, the multiplier of the variable. And x to the n is the variable to the highest power. So n would be, if this was to the 8th power, if it was 8th degree, and the variable was to the 8th power, then that would be the lead one. So n is the highest power. A sub n minus 1 simply means this is the coefficient of the variable to the 7th power, right? In my analogy, if the lead power, the highest power is 8, then 8 minus 1 is 7. What's the coefficient of the variable to the 7th power? And then the variable to the coefficient of the variable to the 6th power, and then coefficient of the variable of the 5th power, and coefficient of variable to the 4th power, and 3rd power, and 2nd power, etc. And again, you see the powers are going down. You know, again, in my analogy, if it's an 8, x is 7, 6, 5, 4, 3, 2, 1. Okay, and then the last thing is the number. All right, so in all of that, with this analogy, what's the value of n in this example? What's the value of n? 7, right? The highest power. So n is simply a 7, and therefore a sub n is 4. It's color-coded, should be easy to figure out, right? And again, the 2 would have been the a sub n minus 1, right? The 6th powered term's coefficient. All right. Honestly, if you don't get all of that, it's not really that big of a deal, because all you're really concerned about is the coefficient of the lead term and the number at the back. All right. So if you completely have no idea what I just said and don't understand any of all those letters, it's not a big deal, because all you have to focus in on is the coefficient of the highest powered term and then the number. And it's from this that we're going to be able to figure out what factors, binomials to try. Because in real life, they're not going to say, is x minus 1 a factor of blah, 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 blah. They're just going to give us blah, 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 and we have to figure out what factors to try. That's where we're heading. All right, so let's write a few things. All right, so with that, then possible binomial. The ugly looking binomial, because it doesn't even spell binomial. And possible binomial factors, and remember, these are roots or these are zeros, result from doing what? P divided by Q. Now, P isn't the 10, where P is factors of A sub 0, the number term, right? And Q is factors of A sub n, the coefficient coefficient of the highest power term, which should be the front term. Okay, so we need the factors of the front term, factors of the back term. And we divide the factors of the back term by the factors of the front term. Let's see how we use it. So again, I'm just trying to go pieces here at first until we can figure out what in the world is going on. All right, so first thing we want to do, we want to list the possible binomial factors of this polynomial. And I stuck the 1 there. It's usually not there, right? This red 1 isn't usually there, but I just stuck it there for clarity. And then, of course, you've got this 6 in the back. Okay, what are all the factors of 6? Would you believe plus and minus 1 is a factor of 6? Would you agree? Right? It is. And another set of factors is plus or minus, let's be orderly, 2. And then also plus or minus 3. And then also plus or minus 6. All right, those are the possible factors. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are all the factors of 6. And of the Q, the 1, the only factors of 1 are plus or minus 1. Which is boring, which means you don't have to fool with it. All right. From this, we need to list all the factors. Why did I stick x in the parentheses? Because the original polynomial's variable is n, x. If the original polynomial had n's here, I'd stick n there. If they were q's, I'd stick q there, right? If these were a's, I'd stick an a there. Okay, so here are the possibilities. I'm going to start with my p-values, and I'm always dividing by 1 or negative 1, so it doesn't matter on that one, on this example. So how about x minus 1, right? That's a possible factor. And I'm going to go to its right and do x plus 1. And I'm just going to keep working my way. And I don't know why I started with negative first and then positive. It doesn't really matter. And so I can have an x minus 2 and an x plus 2, right? And I can have an x minus 3 and an x plus 3. And I can have an x minus 6 and an x plus 6. I'm just showing all the possibilities. See, we had to come up with these possible factors. Can now try to figure out, are any of these 8 factors indeed a factor of that polynomial? I know it's an odd method, but that's the method, and it's what we've got to do. Any questions on getting those 8 polynomial or binomials? We okay there? Let's try to do it again. Let's do the next example. And again, this is a means toward an end. Oh, it's being silly here. Where am I? Wow. All right. Come back, wherever you are. Ever since we updated, it's been a little odd. Okay, so here's the same scenario. You got a polynomial. Again, we're worried about the lead coefficient. That's a 2. And we're worried about the 20, right? And so all the possibilities of 20, all right. Plus and minus 1. Plus and minus 2. Plus or minus 4, plus or minus 5, and then plus or minus 8, no, thankfully, 20, I think that's it, 10, Oh, brother. Plus or minus 10, of course. All right, all different ways you can factor 20. And then the 2 gives us plus or minus 1, but also plus or minus 2. Plus or minus 1, but also plus or minus 2. Okay, how can I, the easiest, make this make sense to you? All right, let's start listing all our possibilities. So I'm going to stop using the color because it's too much of a pain to keep switching. Okay, so if we had the 1 divided by the 1, that would be x plus 1, right? And if we had the 1 divided by the negative 1, or the negative 1 divided by the positive 1, it would be x minus 1. Okay? So that's using the green plus or minus 1 and the red plus or minus 1. All right, that's part. What if we use the plus or minus 1 of the green and the plus or minus 2 of the red? All right. Before I write this, I just want to show you something. Therefore, then I could say x plus 1/2. Do you agree? Does anybody like working with fractions? No. All right. Would you agree that that's the same thing? I know that's abstract. Set x plus 1/2 equal to 0 and solve it. What do you get? X equals negative half, yes? Do 2x plus 1 equals 0 and solve it. What do you get? X equals negative half. So this is really the form we would want. All right? I know that's, again, interesting methodology. So this is 2x plus 1, 2x minus 1. When using that plus minus 2 on the bottom. Woohoo! Isn't this fun? All right, now we got to get to the 2's. So x plus 2 using the ones on the bottom, and x minus 2 using the ones on the bottom. That's pretty easy. And guess what? If you try to use the 2 on the bottom, what's 2 divided by 2? 1, so we already have those covered. So we don't even need those, right? Cutting down the possibilities. All right, 4 is next, right? X plus 4, x minus 4. I'm going off the green, right? The green is always the green divided by the red. The P divided by the Q. And what's 4 divided by 2? 2, so we already have the 2, so we don't have to do that either, right? Thankfully. All right, next one is the 5's. X plus 5, x minus 5. And hopefully you agree with this one, we can have the 2, right? Correct. So look, really should have done this on the first one. Take the red part and put it with the variable and do the green part, right? Make it easier for you to figure it out. Should have said that on the first one, right? Take the red and put it with the variable because it is the coefficient of the variable, and stick the green in. Okay, so the second one then is 2x minus 5. Hey, Mr. Scarfi, one problem is going to take us like a half an hour. Yeah. When we eventually get there, yes. All right, let's do our 10s. Mamma mia. X plus 10, x minus 10. And thankfully, 10 divided by 2 is 5. And we got the 5's. All right, and then finally, x plus 20, x minus 20. And 20 divided by 2 is 10, and we have the 10s. All right, don't turn yet. Because now, again, we have to understand. What is all this for? All of this is to start picking possible factors of this polynomial. And we'll figure out if they work by subbing into the variable and see if we get a zero remainder. Now, this is a cube term, right? It's a third degree. What are the maximum number of factors of a cube term? Binomial factors, maximum. Take a guess, you'd be right. What's the maximum? 3. So at best, 3 of these work. It doesn't have to be 3, it's up to 3. So maybe 3 work, or 2 work, or 1 works. In rare cases, none work. None are whole numbers. So what do we got? 2, 4, 6, 8, 10, 12, 14, 16 possibilities. I'll try to avoid a question with a 20 and a 2 on the quiz or test. That's the idea. All right. Hey, those of you that are non-studiers, yeah, like you're going to remember this, you better study. All right. Where does that lead us? These theorems are used to be able to, as I've been saying all along, factor polynomials. And that's what we want to be able to do today, factor polynomials. Okay, so completely factor. So you're given that. The first thing we're going to do is the rational root theorem to figure out the possibilities. Now, again, I could list P plus or minus 1. I'm looking at the 6, right? Plus or minus 2, plus or minus 3, plus or minus 6. And again, I can list Q plus or minus 1. But once you do a few of them, you can begin to see clearly what to write as the binomial possibilities. So again, we're x plus 1, x minus 1, x plus 2, x minus 2, x plus 3, x minus 3, x plus 6, x minus 6. 2, 4, 6, 8. Who do we appreciate? Ruined my day. All right, so that's a start. It's a third degree example. So up to 3 of these might work. We have 8. So if you are a person that, let's see, I don't believe in luck, but you are extremely not good at things of chance, you might be trying 6 of them before you find the right one. All right, but hopefully we'll give you ones most of the time where they work. So I will tell you this, 3 of them work out of these 8. So, and it's trial and error. You got to try one. So, who wants to give me an attempt? Who wants to pick one? You're just picking one. Just tell me which one you want to use. Come on, somebody. Esther, which one? X plus 3. So this is going to be our first attempt. Okay? So if we use an x plus 3, we're going to do f of what? Negative 3. All right, and this is real life. So wherever the x is, you got to put in negative 3. Right? And we're trying to get what? What are we trying to find right now? A 0 remainder is what we're after. 3 times 3 is 9 times 3 is 27, and it's a negative 27, yes? Negative 3 squared is 9 times a negative 2 is a negative 18. 5 times negative 3 is a positive 15 plus 6. That's a no. 1 out of the way. Now we have a 3 of 7 probability. Who wants to pick the next one? Sarah Mills. X minus 1. All right, we'll make that the second shot. Therefore, we're doing f of 1. All right, belt it out, see what you get. Whoops. So same scenario. Everywhere where the variable is, you're putting in 1, right? And you're hoping you get it on the second try. Yippee! And it worked, right? Mine worked. Did yours work? Better work. Didn't even look at it. What happened? It's gotta work. Doesn't work? Huh? Oh, it's like, what in the world? I know it works. I'm just mindlessly going here. Beautiful. All right, so we're good to go. And we're happy. I'm happy. You're happy. The world is happy. We found the factor. But remember, what are we trying to do? We're trying to factor this polynomial. So now the next step is long division. So now we got to take this x minus 1 and we have to divide it into the original polynomial. And that original polynomial was... Man, I got to get going here. What was that thing? X cubed minus 2x squared minus 5x plus 6. All right, for time's sake, front divided by front, keep going. When you divide this thing, do I even have it? I don't have it. We got to do it. All right, bummer. All right, x cubed divided by x is x squared. X times x is x cubed. Negative 1 times x, negative x squared. Subtract. Going fast, so keep track of me. Error probability is high. Bring down the negative 5x. X divided by x is a positive x. X squared minus x minus is a plus, so that's now a negative 4x plus 6. X divided by negative 4x divided by s, and oh, something went wrong already. What did I do? All right, help me out here. X squared, blah, blah, blah. That's a 2. Negative 2 plus 1. That's good. X squared. Say again.
It's a negative x squared in the first subtraction.
Right here.
Yeah.
I said keep an eye on me. I'm going fast. All right, so that's a negative x squared, and that's a positive, and now we have a negative, so this is a negative 6. Now we're happy. All right, negative 6x divided by x, negative 6, and blah, 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 and it's 0. Yoo-hoo. All right, x squared minus x minus 6. That's what we needed now. So we're working our way toward the end here. So here's where we're at right now. The x minus 1, right, times the x squared minus x minus 6. That's where we're at right now. So to finish this, we got to see if this trinomial factors. Will it always factor? What if it doesn't factor and ultimately we want to find the zeros? How do we figure out the zeros of that trinomial? We use the... What is x squared minus x minus 6? What kind of thing? It's a what? It's a trinomial, and of what degree-esque? What degree is it? It's second degree. It's quadratic. And you can solve a quadratic by factoring, and if you can't factor and you can't take the square root of both sides, you're going to use the, all right, quadratic equation. This is why I try to get you guys in your brain say there's 3 ways to solve a quadratic. Again, you're looking at what you have. Oh, that's quadratic. So anyhow, this one factors, thankfully. Because remember I told you there were 3 factors that worked. And this is an x, and this would be a minus 3 in the back and a plus 2, or a minus 3 in the front and a plus 2 in the back, doesn't matter. And you can go back and look and notice that all 3 of those factors were in our list of 8. Now, if we were graphing this, we would have a 0 at x equal 1, at x equal negative 2, and at x equal 3. And those are the center points of graphing this. And that's where we're heading ultimately, to graph. To graph or not to graph? That is the question. All right. I will come back and do this last one, and maybe, if we have time, Abigail.
So if you wanted to, when you found like all the rational roots here and there, could you just find the 3 possible?
Yeah, but you're hunting around, and there may only be 1. And therefore then you'll do it 7 other times for nothing, because there may have only been 1. So you have to say, is doing it 7 times quicker than long division? But yes, you could. You could. But again, sometimes there's no other ones. All right. I have to refresh your memory on factoring by the sum and difference of 2 cubes, because we can save some time if there are some things we can factor. Earth to tired people and earth to bored people. How can you be bored? Come on. Math, it's awesome. Okay, do you guys remember the patterns on a difference of sum of 2 cubes and difference 2 cubes? Do you remember the pattern? Does anybody remember the pattern? Oh boy. All right. It's a binomial times a trinomial. The sign in the middle of the binomial always matches the sign between the original. So therefore the front one, top one has to be a plus and the bottom one has to be a minus, right? Sign in the middle always matches. It's a trinomial, so you have a sign and then a second sign. The back sign is always a plus. Always. So the front binomial sign middle always matches. The back sign is always a plus. And therefore now we have one other sign after the first term. And it's opposite. Opposite of a plus is a minus. Opposite of a minus is a plus. That's not too hard. Matches, opposite, plus. Always. Matches, opposite, plus. Matches, opposite, and always positive. Always. Okay, how do you get the front term? You take the cube root of the front term. The cube root of a cubed is a. So how do you get this? You take the cube root. What's the bottom one? A, because the cube root of a is a. How do you get the back of the binomial? Again, you take the cube root. Cube root of b cubed is b. How do you get the front of the trinomial? You square the cube root. So just square what you have in front of here, because this is already the cube root. Square that. So that's a squared. How do you get the back? If you see the orderliness, you square the cube root of the back. Again, this is already the cube root, so just square it. Be squared. How do you get the middle? The cube root of the front times the cube root of the back. Again, here is already the cube root, and here is already the cube root, so AB. And that's the pattern. Awesome. What could be more fun than that? It's great. Patterns. Love them. Luke?
So in the first parentheses, will it always end up as like a, or would also could it end up as like a squared?
Yeah, you'll see there are possibilities. So, and I got to speed up a little. I apologize, but you can go back and look at the video here. So again, me doing this first example, this goes with the negative. So I would do binomial, trinomial. Sign in the middle is positive, then opposite, then positive. The cube root of x cubed is x. And the x goes in 3 places, right? And 8 is a 2 cubed, right? The cubed root of 8 is 2. 2. 2. And this one's squared, and this one is squared. So again, it's going to take you a little while to get that pattern, and my front sign is negative. What in the world? One of those days. So it's same, opposite, same. It's what I said. It's not what I wrote. So same, opposite, same. Sorry about that. I'll confuse you even more on a confusing thing. All right, so sign. Same, opposite, positive. Cube root of the front, cube root of the back. Cube root of the front squared. Cube root of the back squared. Cube root times cube root. We should clean it up. X minus 2 times x squared plus 2x plus 4. And that's the factoring of that. Again, I know I'm going fast. Watch the video if you need more help there. I want to tell you this before I get to this last cube example. This could be factored as 2 binomials. I don't have time to do it, but you could factor that by 2 binomials. Just want you to be aware of that. Let me show you this one. Oh, Windows 10. It's driving me nuts. This is a 2 cubed x cubed. This is a 3 cubed y cubed. Okay, binomial, trinomial. Binomial, same sign, positive. First sign in the trinomial, opposite. Last sign of the trinomial, always positive. In the front, the cube root of 2 is 2, the cube root of x is x, 2x. By the way, therefore then the front of this is going to be the quantity 2x squared. And the first of the middle is the 2x, right? Green, the back. Cube root of 3 cubed is 3. Cube root of y cubed is y. That's a 3y. The back is parentheses 3y squared. And the middle is the 3y. Clean it up. Finish it out. 2x plus 3y. 4x squared minus 6xy plus 9y squared. Just clean it up. You got to know the pattern to factor those. You can't factor them without the pattern. This thing would be 2x and x and plus 5 minus 4, and I'm sorry, this is 2x and x squared. Believe it or not, it factors that. What is this in the purple box? What is it called? Does it factor? Yeah, so really you end up with 2x plus 5 times x plus 2, x minus 2, right? And you have the 3 factors. All right, tonight we got to get you to practice, though, this whole process using the remainder theorem and rational root theorem. And you'll do some factoring like that. Be careful. You got to get it settled out tonight and get it in your brain. I've taken 2 days there, and I really can't take any more. So it's this that we'll use to graph. All right, have a great day.
Yes.